My pleasure to introduce Marco. Over to you, Marco.
Jayesh, thank you so much for that introduction. I really appreciate that. And thank you, Kimberly, for having me here at the Process Industries Conference. Again, my talk today is the industrial automation control system design, especially the value and need for industrial automation control system security, facility testing, but also site acceptance testing. So I'll go ahead and start now. Some of the key things here is that, especially with automation systems from the decades past, many years ago, as you know that I've been doing this for some time, is that control system vendors did not have to engineer for cybersecurity back in the day as a priority, or adapt their technologies to support the operational safety and control mission. However, engineering did have to worry about system bugs that could impact safety and reliability. That being said, cybersecurity today, and as if you look at the technologies, we've went from introductory level control systems like that Foxborough 1 system that you saw on the previous screen, to highly complex systems of today with much more computing power, higher processing speeds, and also networks to be able to back those speeds. So control system vendors today have adapted their technologies to support the cybersecurity mission, allowing for better architecture and methods of security. And many have created their own cybersecurity guidelines and references for proper implementation strategies. And these are not 1, 2, 7-page documents. These are typically anywhere from 30 to 200 pages. And so security from 20 years ago, which wasn't really prevalent in our industry, has really come a long way. Now, with that being said, so does the engineering aspects of conceptual design, what we're going to do as far as what we're going to deploy as an architecture for our distributed control systems, our safety systems, and what we're going to do for remote access. Many of the vendors have come a long way. I'm sorry if I don't have all of them here, but we have come quite a bit of a long way. The reality, though, is that integrators and vendors, delivery services groups are under the pressure and time constraints to provide and deliver operational design features of the control and safety system. And oftentimes in the actual procurement docs or the system docs, you may not have a cybersecurity requirement specification. And so when it comes down to the actual delivery services group, sometimes there's a lack in need, or I would say tabling security for the tail end, but main focus is trying to get the engineering of the function blocks, the codes, the IO, the actual graphics built, tested, and so forth. So in many situations, cybersecurity, while important, is usually less of a priority in the preparation for your traditional factory acceptance testing. And I think many of us here that are probably in the audience can attest to that. So here's the thing. Embedding security in at design. It's very important, especially in today's ever-connected world. The design and delivery should have cybersecurity at the core of it, the mission. And that's leading up and through to actual handover. So it must be consistent leading up to FAT and through to site acceptance testing. And the reason that's important is because we often find deltas and gaps in between what we saw, what we tested, and what was delivered, and how it was turned on, and handed over. And it's very important that we are fluidic with our security requirements from the very beginning, all the way up into FAT, up and through SAT. It's very important, especially once you get it on site and now you have other systems coming into that environment. So planning. It's very important from a planning standpoint that we really have a good strategy, because here's the thing. Cyber actors and nation state actors will take advantage of issues within the supply chain, such as system capabilities, misconfigurations, lack of vendor and integrator awareness and culture. Those are vectors those are weak spots into your control system. And all of these could cause weaknesses and flaws in the system at site and during operation. So we are only as strong as our weakest links. And so the key factor there is planning is huge, and it's number one. And making sure you have a cybersecurity plan in place. Even for rip and replace, brownfield, or even new system builds, it's very important. Security FAT and security SAT are essential tasks that must be part of every project. What I'm saying there is plan for hours. Plan additional time into your projects. It doesn't have to be the complete overhead type project work that you're going to have for your configuration and automation development, design, and HMI graphics, but it will be a certain percentage. And depending on system complexity and system build, that will all be deterministic in what that looks like. Having an external assessor to test and verify is an important part of the process, and is best when the assessor is outside that of the vendor and the owner operator for security control verifications. More times than not, many vendors or asset owners either self-assess, or they have the vendor that's building the system or integrator that's building the system do the assess. And sometimes there's things that could be missed, things that are not deployed. And so having a security assessor that's outside of that loop to be able to look at that and go in and do a verify and assure type FAT, security FAT test is very, very important. And you'll be surprised some of the things you may find. And again, it comes back to being under pressure. The planning and execution is key. But here's where my point is that for the ISA members that are in the group and the ISA or the folks that are following any of the IEC 62443, this is specifically stated and spelled out in the 3-3 standard and the approach. So in section 7, FR3, which is system integrity, there's 2 bullet points. So it's under 751 under the requirement, and under 753 requirement enhancements that are laid out in that actual standard. So if you have a copy of the standard, read up on those. It is being spec'd out. So if your company it is following 62443 or a global standard, it is a best practice and recognized and generally accepted good engineering practice. Which then goes back into planning and execution. You have to be able to bank the time to be able to really do a good thorough assess. And it really starts at the very, very beginning in conceptual to initial design. Creating the security requirements for the vendors to be able to follow. Having a cyber requirements spec is hugely important. And then once it gets into detailed engineering is actually creating your security test plans, your checklists, your function testing for the security aspects of it, aside from that of your traditional FAT. And then you get into the system build, and then you're prepping and becoming ready for your actual security FAT. And then once you do your FAT, and you can see up at the very top here, there's kind of a checklist that's developed that you want to be able to have. Not every company will have the same type of checklist, but ideally you want to be able to create a checklist from everything that's on the network, every node that is on the network, whether it's safety, whether it's an operational PLC or distributed control system or SIS CPU controller. You need to be able to have these within your spreadsheet and documenting all the security features and go through a checklist function to see if they meet a certain level of hardening, because that's what it comes down to, is seeing what level of hardening within your system that you have rolled out. And then post FAT, once you went through your findings and you've had time for either the vendor or the third party to help implement some of the mitigations or things that were found to mitigate, then once you get out to SAT, to the commissioning, you really want to see if anything has changed. And what we typically see is everything from portable media, USB sticks, nodes on the network that have changed IP assignment, naming convention, and have also maybe even defeated or disabled antivirus, application control, and many other things. Added switches, moved nodes on the network, just as I said. So you want to be able to document that and understand what has changed and be able to document that and bring it up to the attention of the asset owner. And then operate and maintain. Everything in cybersecurity, especially within 62443, is a life cycle. So you want to assess, you want to develop and implement, and then you want to run and maintain and rinse and repeat, as my friend Andy Bachman likes to say, is it needs to be a continuous process. Some of the things that you want to go through, especially at FAT, is system hardening. Operating systems and the CPUs, whether that's your OS, your PLCs, your distributed control systems, your SIS, you want to identify, document, and understand what is your installed firmware, your installed applications, your running applications, removal of unapproved applications, identify application ports, protocols. If the firewall is enabled on the host, and is it following vendor guidance? Is the vendor deployment following vendor guidance? Locking down of unused ports, malware detection and prevention. And here's the thing, especially in today's world, proof of backups and a backup plan and restoration process. Very important to understand and identify that and document that at FAT before you inherit it at your facility. Other pieces to this is obviously the network hardening. The communication links in between, whether it's serial or now with Ethernet, really identifying that and looking at system hardening and network hardening. With network hardening, we're looking at appliance hardening. In other words, are your firewall and switches, are those locked down? Do those have open ports and protocols that are known avenues in for attack vectors that are, say, clear text protocol? In other words, when you log in, can that be seen on the actual wire from a reconnaissance standpoint? Identifying what ports, protocols, switch and firewall configurations is important. Just because you have a firewall appliance does not mean it is set up correctly. So you may get to check the box that you have one, but those configuration rules are extremely important in your distributed control system and even at the perimeter, at ingress and egress. You've got to be able to look at that. You've got to be able to test it and understand what you have. These network appliances, they do have management ports. So who has root access? What is the account access? Is it default by nature? Can this be looked up by a cyber actor? Management access ports, using security not my problem or SNMP. If these things are not locked down properly, they could be chatty on your network and could be vectors in and avenues into your control system. And then lock down unused ports, very similar to what we did in system hardening. And then, yes, even with the network devices, proof of backups and having a plan and restoration process in planning. And so I think these are key fundamentals. But if you notice in the very bottom right-hand corner where I say run, test, document findings, every one of these things in your checklist is going to be run, test, document findings. Don't take people's word for it. Go for it and really actually at FAT test these things to make sure, especially if you're the verifier and assessor, that you're testing these out and you're checking these out and you're date and time stamping these things. Malware detection and prevention, I see this quite a bit. Antivirus is something that many of the vendors support. They've documented and dictated what vendors, what actual software versions of antivirus, including application control or allow listing. The thing is that what you find, especially at FAT, is that antivirus may be installed, but it may not be active. And if it is active, it may not be scanning the whole machine, or it may only be scanning parts of the machine or parts of the actual drive that's only protecting that part of it. So understanding what the file path, file name, file size, everything within that part of it is very important. And you really have to do your due diligence there, especially before it goes out to the field. Run, test, document findings. Other pieces is intrusion systems. Many of the systems that we're seeing going out today have the capability of providing system logs, especially from the network and the host. And if you are going to integrate that in, it's much better to do it up at the actual configuration side and get it rolled out prior to FAT, and then you have it in place. So host intrusion detection systems, network intrusion detection systems, and prevention are key critical components that you should have at least ready at FAT. Because what happens is that these systems, if you roll them out at SAT and they weren't really tested or documented, they could also be avenues into your control system after you spent much of your time trying to capture these at FAT. Other things is important, role-based access deficiencies, access control, default usernames, credentials, lack of security around group policy, logging, audit trail. These are some of the things that we find that are very weak at FAT. And then including remote access, verifying whether you have an architectural design that supports it or the actual ports, protocols, and privileges laid out that would allow it. If it's a system that's not going to have remote access, making sure you run tests to confirm and to turn off and disable those is very important. And then creating alarms around that. So the idea here is making sure that you have secured your system from remote access, the people, the process, and the technology. Portable media, folks, it's here to stay. It's something we're going to be dealing with for some time. USB access is something that we have to do better at, even getting up to FAT and definitely at SAT. Many times at FAT, we've already documented what sticks or what portable media is going to be used. And when we go to SAT to do a conclusive findings, to look to see what's changed or what's been connected, we find new USB sticks that were not documented, new devices that have been connected up, and sometimes you even find Apple apps and things like that that should not be there. Scanning, logging, very important. Laptops and iPads. The mobile worker is very important. Great things have come with technology, but making sure that those are locked down and also have and are part of the FAT and SAT, system and network hardening. This is an ideal sample of a security checklist for FAT. This is something that we've developed, but it's really a condensed version. Ideally, what you're looking at here is something you can go through and confirm whether you have, and this is just an example, we've got computers, we got OS versions, we got if it's been patched, if antivirus is installed, who the manufacturer is, if it's active, it's updated, is application installed, application control installed, is it active? Remember, because it's installed doesn't mean it's active. Is the host firewall enabled? Does it have default users? Does it have default passwords? So if we come here and we say, does it have default passwords? We can nail things down and say, okay, does it have antivirus installed? And then we can come in and we can say, no, it doesn't. Sorry, no, it doesn't. And so you can get a list of what the first ones you need to go and knock out quickly. And keeping that list up to date is extremely important. Making sure FAT, you have a good process in place for documentation. And don't forget the wireless. Folks, the technologies that are coming out today, from motor control centers, variable frequency drives, smart instrumentation, have got Bluetooth enabled, Wi-Fi enabled most of the times with default. And oh boy, didn't you want that in your process control? Maybe not. Maybe it wasn't spec. You weren't aware that these things came with them enabled. In your FAT, you need to find that, document it, and disable those if they're not going to be used. If they are going to be used, make sure that you have a security practice in place to deploy those. Testing. I'm at the very tail end of the discussion here, but testing is hugely important. We talked about it through the previous slides of what you should have on your checklist as a bare minimum. But when you're testing, looking at the robustness, understanding what does the denial of service type flood attack do to your control system network, in FAT is the prime time to be able to identify that. If you flood the primary network, does it fail over to secondary? If you're flooding the secondary network and start toying around with the primary network, what happens then? Does the system flap? Does it go into fault? Does it error? Do motors start tripping? These are the things you need to be able to understand and identify within your robustness testing in a controlled environment at FAT. Vulnerability scans, spoofing, exploitation, ARP floods, ARP poisoning. These are terms to be able to disrupt the network, because most of all these systems nowadays are reliant on a network. And then denial of view. What does that look like for an operator? Do you get an alarm whenever you actually lose your graphics or lose connectivity to your PLC? I would hope so, but these are things that you need to test. Run tests, document findings. Because here's the thing, on the blue side, ideally you want to look for your blue lines, understanding what zones, what conduits you have in your FAT, and then at SAT, confirm that if anything has changed from the blue lines that you saw in FAT, confirming what has changed, but also what you see in red is all the new communication data flows that happened that were not there at present at FAT. SAT is where you start connecting into the remote, to the enterprise systems. You may have remote access and uncontrolled VPNs that could get to the engineering workstation. So these are the things you want to be able to capture, identify, and then do a delta in and capture and identify and document at SAT. And then this is just the SAT checklist, and you can see over here from the very far left all the way over, we've updated our system with vendor approved patches. We've got antivirus installed, antivirus is active, antivirus is updated, application controls is installed. It's active, firewalls enabled, no default users, no default passwords. We have role-based access, and role-based access is enforced. So again, your checklist may vary, but these are some of the key elements and key functions that are important. And that is what you should be doing at FAT for security and SAT at security. And these all follow into the structure of your 62443 standards. And that's kind of the end of the talk. If you need anything or any help with that, let me know. I've got the actual Excel templates for those that want to reach out through ISA. I'll be happy to hand the Excel spreadsheet out. And this is a way to contact me. And then just one last final word is that ISA Connect is a great place to collaborate and coordinate. And so as you go into, if you're a member of ISA, there's many communities that you can join. There's a lot of great functions here. And before I hand this over to you, Kimberly, I'll let you wrap this up. But there's so many different divisions, whether you're analysis, batch control, building automation, chemical and petroleum industries. And there's one here that I'm a part of called Safety and Security Division. And we've got over 2,000 members. It's very strong. So it's process safety and it's cybersecurity. So I encourage you for those that are out there to join, and I will go ahead and close and open it up for questions. Sorry, Kimberly, if I went long.
No, that's fine. When we're on a roll, we have to keep going with these technical discussions. So thanks again for the plug about continuing these conversations long after this live event is done via our ISA community platform. So again, as a reminder, for those of you that wish to ask a question, please use your Q&A icon to enter your text, and we'll get some items in the queue and see if we can challenge Marco before we let him go. I'll wait a few minutes. And I see a few coming in.
Okay.
One of the comments was, again, of course, thank you for the very informative presentation. Is there a checklist template to share? And you did mention that.
Yes, I can get that over to you, Kimberly, so you can put it up. It's just a spreadsheet. It's just something that could be a good start and go by. It's not anything really special, but these are just some of the fundamental cores. Sure.
Okay. So what we will do for those, if you go back to the auditorium, as I mentioned, you can download a PDF copy of the presentations that you missed up to 30 days following this live event, and we'll also post that document as well attached to this presentation.